Have you ever been puzzled by sequences like this? Well, in this video, we're going to be going over arithmetic and geometric sequences. Let's do it. Alright, so to solve geometric and arithmetic sequences, we first need to know how to solve them. So let's look at the formulas. For arithmetic sequences, the formula is f of n equals f of 1 plus d times n minus 1. Alright, let's look at what all the components mean. So f of n. So your n is just the nth term. So that's the term we're looking for. So if you're looking for the 7th term, you would write 7 here. But you would also write 7 over in this n. Next, f of 1. This is just your first term. So in a given sequence, the first number is what you would write here. So if your first number is 3, you would write 3 here. Next, d. So d is your common difference. So in an arithmetic sequence, between term and term, you go up by a certain number. So that's called your common difference. So for example, let's look at this sequence I've given right here. 3, 6, 9, 12. Alright, so we know that it's going up by 3 each time, right? So that's our common difference. Next, our first term is the 3. And if we're looking for what this 5th term is, that's the nth term. So now that we know that, let's use this sequence to fill out this as an example. So f of 5 equals 3 plus 3 times 5 minus 1. Alright, 5 minus 1 is 4. 3 times 4 is 12. So that's just 3 plus 12, which is 15. And that's your answer. Now let's know how to solve a geometric sequence. So the formula for a geometric sequence is f of n equals f of 1 times r to the power of n minus 1. Alright, so let's look at what our components mean. So f of n and f of 1 are the same thing. This is the nth term. So the term you're looking for, and this is the first term. So the first term given in a sequence. Now your r. So r is the common ratio. So the difference between a geometric and arithmetic sequence is, while arithmetic goes up by the same number, geometric goes up by the same multiple. So what that means is, if you look at this sequence, 3, 9, 27, 81, right? Each time it's going up times 3, not by 3, it's multiplied by 3. So 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, and so on. So it's multiplying by 3 each time. So that's our common ratio. And then our n is just the nth term again, and then you're subtracting 1. Alright, let's use this sequence to find out what the 5th term is. So f of 5 equals 3 times 3 to the power of 5 minus 1. So that's 3 to the power of 4 times 3. 3 to the power of 4 is 81. So 3 times 81. And that gets you 243. And that's your answer. Alright, now let's look at 9 different arithmetic and geometric sequence problems. So what is the difference of the 45th term and the 20th term of the sequence? So we're given the sequence -5, 0, 5, 10, 15, and so on. So in this sequence, we can see that each time it's going up by 5. So we need to know what the 45th and 20th term is. So since it's going up by 5 and not multiplying by a number, this is an arithmetic sequence. This is an arithmetic sequence. Alright, so we need to use our formula. So we're looking for the 45th term first. So f of 45 equals -5 plus 5 times 45 minus 1. So off the bat, this is just 44. So 5 times 44. 5 times 44 is 220. So now we're left with 220 minus 5, which is just 215. So f of 45 equals 215. Alright. So now we know what our 45th term is. Now we need to know what our 20th term. So now let's solve for 20. Alright, so f of 20 equals negative 5 plus 5 times 20 minus 1. Alright, so 20 minus 1, off the bat, that's 19. Multiply that by 5, that's 95. So 95 minus 5 equals 90. So f of 20 equals 90. Alright, now we have to do 215 minus 90 because we're solving for the difference. So 215 minus 90 is 125. And that's your answer. Alright, next. What is the sum of the next three terms in the arithmetic sequence? Negative 57, negative 26, and 5. Alright, so each time it's going up by 31. So we could use our formula here, but it's actually quicker this time to just add. So 5 plus 31 is 36. So that's our first number. Then 36 plus 31 is 67. Now 67 plus 31 is 98. Alright, now we just have to add up 36, 67, and 98. Alright, 36 plus 67, that's 103. And 103 plus 98, that's 201. And that's your answer. Next, what is the sum of the 18th and 24th terms of the sequence? Negative 21, negative 17, negative 13, negative 9. Alright, so this is an arithmetic sequence because we're going up by 4 each time. So let's solve for the 18th term. So f of 18 equals f of 1, which is negative 21, plus 4 times 18 minus 1, which is just 17. So 4 times 17 is just 68. So this becomes 68 minus 21. 68 minus 21 is 47. So f of 18 equals 47. Next, let's solve for 24. F of 24 equals negative 21 plus 4 times 24 minus 1, which is, that's just 23. 4 times 23 is 92. Now this entire thing simplifies to 92 minus 21, which is 71. So f of 24 equals 71. Alright, so we need to find the sum. So 71 plus 47. That equals 118. And that's your answer. Next, what is the 17th term of the arithmetic sequence? Negative 51, negative 32, negative 13, etc. Alright, so in this arithmetic sequence, each time it's going up by 19. So now that we know that, let's solve for the 17th term. So f of 17 equals f of 1, which is negative 51, plus 19, because that's the common difference, or whatever it's going up by each time, times n minus 1. And in this case, n is 17. So 17 minus 1. 17 minus 1 is 16. So this is just negative 51 plus 19 times 16. So 19 times 16 is 304. So 304 minus 51. So 304 minus 51 equals 253. And that's your answer. Alright, the third term of an arithmetic sequence is 10, and the fifth term is 28. What is the value of the 31st term? Alright, so we know that f of 3 equals 10, and f of 5 equals 28. And so now we're looking for f of 31. Alright, so how we solve this is we need to find the midpoint. The midpoint of 10 and 28, because we're looking for f of 4. So f of 4 is just between 10 and 28, which is 19. So that's your f of 4. Now that we know this, we can list this out as a sequence. So 10, 19, 28. And we can clearly see a pattern that's going up by 9 each time. So we can trace our steps back. So we can go 10 minus 9, which is 1, and that's f of 2. And then we can go back again, and it's negative 8, and that's f of 1. Now we can solve, because it's actually really simple. So we're looking for f of 31. So f of 31 equals negative 8, because that's the first term, plus 9, because that's the common difference, times 31 minus 1, which is just 30. So 9 times 30 is 270. 270 minus 8 equals 262. And that's your answer. Next, what is the 8th term of the following sequence? 2.8, 8.4, 25.2, and 75.6. Alright, so just by looking at the sequence, we can see it's a geometric sequence because each number is 3 times the last number. For example, 8.4 is 3 times 2.8, 25.2 is 3 times 8.4, and 75.6 is 3 times 25.2. Alright, so we know it's geometric, so let's solve for the 8th term using the geometric sequence formula. So f of 8 is equal to f of 1, or the first term, and in this case that's 2.8, times the common ratio, which is 3, to the power of n minus 1. So n in this case is 8 minus 1. Alright, so this simplifies to 7, and then 3 to the power of 7 is just 2,187. And now we just have to do 2,187 times 2.8. And that gets you 6,123.6. And that's your answer. Next, what is the 7th term of the sequence? 284 and 4 ninths, 213 and 1/3, 160, 120, and 90. Alright, so this is a geometric sequence because each number is 3/4 of the previous number. For example, 90 is 3/4 of 120, 120 is 3/4 of 160, and 160 is 3/4 of 213 and 1/3. Alright, so this is a geometric sequence. So that means we could do the formula to find the 7th term. However, if we ended up doing the formula, we would have to compute 284 and 4 ninths times 3/4 to the power of 7. That's a lot of math to do. So instead, what we can do is, we can find the 7th term by using the 5th term. So we're given the 5th term here, which is 90. So we need to find out what 3/4 of 90 is. And we need to find out what 3/4 of 90 is. So this just becomes 90 times 9 over 16ths, or 9/16 of 90. Alright, so 90 times 9 is 810. And 810 divided by 16 equals 50 and 5/8. And that's your answer. Alright, what is the sum of the next two terms of the sequence? So we're given the sequence 14, 18, 22, etc. Alright, so this is an arithmetic sequence because each time the common difference is 4 because we're going up by 4 each time. Alright, so now we can solve for the next two terms. So either we could do the formula or we could just count. So I'll do both ways. First, let's do the formula. So we're given the first term, which is 14, and we're given the common difference, which is 4, and we need to find out what our n is. So our n in this case is the 4th term and the 5th term. So let's find out the 4th term first. So 4 minus 1, and this equals f of 4. Alright, so 4 times 4 minus 1 is just 4 times 3. 4 times 3 is 12. 12 plus 14 is 26. So f of 4 equals 26. Next, we need to find out f of 5 because that's the next term. So f of 5 equals 14 plus 4 times 5 minus 1, which is just 14 plus 16, which is just 30. So now we know that our f of 4 is 26 and our f of 5 equals 30. So now we just have to add up 26 and 30, and we get 56. And that's your answer. However, if you wanted to count, you could also do that by just adding 4. So that would be 26, because 22 plus 4 is 26, and 26 plus 4 is 30. And now you just add them. So 26 plus 30 equals 56, and that's your answer. However, if it's a larger number and you're not sure how to do it, use the formula. But if it's a simple problem like this, I would suggest counting. Next, what is the sum of the 61st and 83rd terms of the arithmetic sequence? Alright, so negative 24, negative 18, negative 12, and negative 6. Okay, so this is the arithmetic sequence as stated, and it's going up by 6 each time. So let's write out for the 61st term first. Alright, so f of 61 equals the first term, or f of 1, which is negative 24, plus 6 times 61 minus 1. So that's just 60. 6 times 60 is 360. 360 minus 24 equals 336. So now we know that f of 61 equals 336. Now let's find f of 83, or the 83rd term. So f of 83 equals negative 24 plus 6 times 83 minus 1. 83 minus 1 is 82. 6 times 82 is 492. 492 minus 24 equals 468. So f of 83 equals 468. Now we just have to add 468 for f of 83 and 336 for f of 61. So that equals 804, and that's your answer. Alright, that's it. Thanks for watching. If you found this video helpful, please make sure to show your support. These videos take a lot of effort to make, and I would really appreciate it.